In this video, I'm going to show you how to create a simple generative artwork created only from lines using Max MSP. This artwork is not my own invention, it's from the book Generative Design. There it was implemented using JavaScript and the P5.js library. And as an exercise, I wanted to see how I can create this cool installation, these cool patterns emerging from combinations of lines in the world of Max MSP. Implementing something like this means exploring jitter matrices, jit.gen, and generative geometry using jit.gl.mesh. Very cool stuff. Let's get into it. I am back on the website for the generative design book. And from the list of sketches, today I'm interested in this one right here, the first one from the shape category. If I click on this and start playing around with it, you will see that it is pretty self-explanatory. The position of my mouse determines which kind of shape I'm getting, and the shape is made out of lines radiating from the center. The X position of my mouse determines the size of the shape, and interestingly, the closer I get to middle, yeah, look at it, if I'm exactly at the middle, the shape even disappears, but if I deviate from the middle, it starts radiating outwards, kind of following my mouse. The y-axis, the vertical axis, determines both the amount of lines radiating from the center, as well as the thickness of the lines. So much so that if it's too thick, it just looks like a sphere, looks like a circle. So how are we going to create this using Max? Well, we have to look at the world of jitter. Right, and to start with, I've already set up the system where I have a jit.world, my rendering context. I gave it a name and I enabled some important attributes. Floating 1 is going to make sure the window is always floating above my patch. FSA A1 is going to apply full scene anti-aliasing, so the image is going to look a bit smoother. And erase color 1111 is going to make sure that if I turn on my context, the background is going to be white, just like the sketch itself. On top of this, I've created this load bang object that sends the message send window idle mouse 1 to my jit.world object, and that is going to make sure that information about the cursor is sent out from the last outlet of jit.world when I'm hovering my mouse over the window. I then did some trickery to get the normalized x and y coordinates, so values that go from 0 to 1. I did this by routing the mouse idle messages from the outlet, then slicing the first two elements using zl_slice so I get the pixel coordinates, and then I used the vexpr object to divide this value by the total window size, the size of my window that I got through the getAttr object, and then the result is indeed the normalized coordinates. If you really want to look at this in detail, figure out how it works, you can either pause the video or download the completed patch from the video description and examine these objects yourself. I am right now, however, more interested in drawing lines. So there are a few ways where we can draw lines in Max MSP, a few ways of drawing lines in jitter. But today I'm going to use jit.gl.mesh, jit.gl.mesh. It's a bit like a tongue twister, jit.gl.mesh. And this is going to let us generate geometry from jitter matrices. And I need to tell this object a few things, such as the name of my jit world context, which is hello shape. And then I need to give it some important attributes. The most important one is draw_mode. So how is it going to interpret the incoming data? Is it going to try to draw polygons or points or lines or a bunch of lines connected together? And in this case, I think I need to say lines. I hope this is correct. We will see the result in a bit. And finally, I can give it the attribute color to to tell the color of the shape that is being drawn. And this is it's not 111. The color is 0.0.0. So it's going to be all black, again, just like our example right here. Cool. So what is going to happen now? Well, this object, as you can see, it has a lot of inlets, but we are going to use the first inlet. We are in fact going to send a jitter matrix into the first inlet, and the information in the cells of this jitter matrix is going to be interpreted as coordinates in our imaginary 3D space for things to be drawn. I can showcase this very easily by using the jit.noise object. I can tell the amount of planes for this matrix. It's going to have 3 planes because I want the x, y, and z coordinates. I can make it float 32, and I can make its size, let's say 25. Right, so what is going to happen when I send this guy, when I send a bang to jit.noise, and when I send this matrix to jit.gl.mesh? Well, hopefully, I hope I'm going to get a bunch of random lines. Yep, there we go, a bunch of random lines. Each time I click this, I get a bunch of random lines on the top right corner of the screen. And why is it on the top right of the screen? Well, let's look at what exactly is coming out of jit.noise. We can visualize this information, but in this case, the information coming out of jit.noise is being interpreted as coordinates, not as pixel values. So I can use jit.cellblock to visualize this information as numbers. I can send jit.noise. Also here, I can reinitialize the object, and I have all these numbers here. But this is only the first plane out of my 3 planes. And if I want to see all planes, all possible information, I can create a message box, say plane -1, comma, call width 120, and send information here. And there we go. So each cell has a value between 0 and 1 randomly generated. Right, and as you can see, that just generates these pairs of points around which a line is drawn. That is how draw mode lines, the lines draw mode works with jit.gl.mesh. It takes these values as coordinates, as 3D coordinates, and it draws a line from here to here. And then it moves on to the next cell and draws a line from here to here. And then it draws a line from here to here, and so on, and so on, and so on, until it's out of cells, it's out of coordinates, it's out of points between which to draw lines. So that is the important part, right? Draw mode lines takes pairs of cells and draws lines between them. Now, if we want these random lines to kind of radiate from the center, the first thing we can do is to change the values coming out of jit.noise so that it's not between 0 and 1, but it's from -1 and 1, right? So that it doesn't only go to the right and only go up, but it can also go left and down through negative values. A simple way of doing this is through the jit.map object. I can give this object the attribute map, and then I can put the scaling information. So from 0 to 1 to -1 to 1. So scale the incoming values that go from 0 to 1 to a new range of values that go from -1 to 1. And doing this, and then clicking this little button here, there we go, is going to create again a bunch of lines, this time centered around the origin, centered around the middle point. And again, this is not this, right? This is not the P5JS sketch, but we are getting there. We first have to figure out how to draw lines in a generative way, which we have just done. And now we have to figure out how to make these radiate from the center instead of being connections between the randomly generated vertices right here. And one way we can do this is as such. Let's imagine a situation. Before we realize things, let's imagine an ideal world where there was an empty cell between these cells. So imagine between each of these cells, each of these values, was another cell, another value that was always 0, 0, 0. Right? If that was the case, then jit.gl.mesh would take this information and say, well, I'm going to draw a line from here to 0, 0, 0. The center point. And then I'm going to draw a line from here to 0, 0, 0. Then I'm going to draw a line from here to 0, 0, 0, and so on, right? So then I would have a bunch of lines technically radiating from the center. Now, what is the best way to do this? Well, I actually had to look at a lot of jitter objects to figure this, but the object we need, or one of the objects we can use, is called jit.multiplex, which is an awesome name for a jitter object. And what it does is that it interleaves 2 matrices into 1 matrix. And this is exactly what we need. Here's what I'm going to do. I'm going to create the jit.multiplex object. I'm going to put the randomly generated values here to the left. And for the right side, I'm going to create a new empty jitter matrix. Jit.matrix 3 float 32. And the important part is that this has the same width or the same dimensions or the same resolution as the first jitter matrix, right? So if this is 25 cells long, this is also going to be 25 cells long. Now, when I initialize a jitter matrix, it's empty, so all of these cells are going to have values of 0. They're all going to be 0, 0, 0. Then I can take my button and I can also send a bang to this jitter matrix right here. So now when I click this button, it's going to first, and remember, max is always from right to left, it is first going to trigger this empty matrix. It's going to load it up in my jit.multiplex's right inlet, and then it's going to generate a bunch of random values, map them to -1 to 1, and then send that into jit.multiplex. So these two are going to be interleaved, and the result will go to jit.gl.mesh and also to jit.cellblock. And then if I have my calculations right, I'm going to get these beautiful visuals. And honestly, these are already beautiful on their own, right? So we can try and make some nice artworks just using this. Simple but elegant. And if I look at my jit.cellblock, I've achieved exactly what I wanted. I'm interleaving the random values with a bunch of values of 0, 0, 0. And if I want, I can make this automatic. The second outlet of jit.world is going to send a bang per frame according to our frame rate. If I connect this to the button, I can actually just generate a bunch of random lines and I can generate these cool animations. If I want to, but that is not why I am here, right? I want to eventually recreate this nice art installation, this nice generative artwork. And to do this, well, I need to figure out a way to not randomly generate points to which draw lines from the origin, but actually order my 25 elements, and let's keep it at 25 for now. I'm going to order my 25 elements generatively in an ordered way around the center point in a circle. Now, this is the tricky part. This is the part where we might need to use not jit.noise and not jit.map, but instead jit.gen. Jit.gen, as you might know, is a sub-programming language in Max that lets you create these intricate algorithms which are applied onto each cell of the incoming jitter matrix. So let's imagine this. Let me make an empty jitter matrix again, jit.matrix, just like the one here, 3, float 32, and a dimension of 25. There we go. And again, when I click this, I want to send my empty jitter matrix through jit.gen, and then ideally, instead of these random values, I would calculate the position of each of these 25 cells equally spaced around the center point, ordered like a circle. So how can we do this? Well, if I lock the patch and double click on my jit.gen, I'm going to have the nice gen patching interface. I can unlock this and I can delete the objects I don't need. I don't need into, I don't need plus, I do need in one and out one. Right, actually, technically I don't think I need in one, but doesn't matter right now. Okay, now if I want to define points in space in a way that I would organize them like points around a circle, or if I'm thinking of circular coordinates, the right term for this is polar coordinates, right? So I need to create the object pole to car. I want to define my points in space in terms of polar coordinates, and polar coordinates works through a radius and an angle. Instead of specifying the amount of x and amount of y and amount of z, I'm going to say, well, my position in space is this far from the center, and I have to rotate it this much around the center point to reach my specific point in space. Now, I am going to calculate it like this, but I do have to convert it back to Cartesian coordinates, the x, y, and z coordinates, because jit.gl.mesh and jitter in general is going to interpret points as Cartesian coordinates. So we are calculating points in polar coordinates, and we are converting them to Cartesian coordinates so that they are used by jitter in the appropriate manner. So whatever comes out from pole to car is going to be x and y coordinates in terms of Cartesian coordinates, and I can pack this into a vector, and vector is essentially a list. So x can be this one, y can be this one, and the last 0, the third element, I'm not going to do anything. This is not three-dimensional, so the z value can always be 0. The z coordinate can always be 0, and then this is going to go out. All right, cool, but how are we going to calculate our radius and angle? Well, the radius is fixed, right? I mean, it is a value that changes in the P5JS sketch It's a bit laggy right now because this window is not focused, but these all have the same radius, right? All the lines have the same radius. And right now, to make things easier, let's just imagine the radius is a fixed value of 0.5. Right? And in jit.gen, I can do tricks like this. I can create an object, name it 0.5, and it's just a value of 0.5. And I can send it here, and now it's the polar radius. Okay, but the angle is going to change, right? And the angle is going to be measured in radians, and in radians, a complete rotation is from 0 to 2 pi, 0 to 2 pi. And this is such an important value. There's actually a constant, an object in jit.gen that is named 2 pi, and its purpose, its entire purpose in life, its entire purpose in existence is to send out the value 2 pi for our calculations. Okay, well, then I need to take each cell's index number, right? So are you the 0th cell? Are you the first cell? Are you the second cell? Are you the third cell? And so on, and scale it to a range of 0 to 2 pi. And if I do this, I've generatively generated the right amount of angles, the right amount of polar angles for my polar coordinates. So essentially, I need to use the cell object, which is going to give me the cell coordinates of the input matrix, right? So for the first cell, it's going to give me 0. For the second cell, it's going to give me 1, and so on, up until the 25th cell, it's going to give me 24. So I need to take this and I need to apply the scale object on this, right? So this goes into the first inlet of scale, and then I'm going to say, well, this incoming cells, right? The incoming indices, the incoming values from cell go from 0, and that's the second inlet. They go from 0 up until the dimension of my matrix. And in this case, it's 25. I'm not typing 25. I'm using this dim object so that if I change this from 25 to something else, that something else is going to be sent out by dim. So the cell index value comes in, the coordinates of the input matrix come in here. These go from 0 to up to my dimensions, and I want to scale this to a range of 0 to 2 pi. There we go. So it looks complicated. It looks like it has a bunch of legs or a bunch of heads, but this is a simple scaling operation. And whatever the result is, just take that as the polar angle for that specific cell. And this simple algorithm should be enough. Is it going to be enough? Exciting. Let's find out. If I click this button, boom. Now it's much more orderly, it's much less random, and all the values are evenly spaced out. And since I did not use the value 25, I can change this to something like 5. And now I have 5 lines, perfectly distributed along an imaginary circle. Or if I want to create something crazy, I can say, give me 500 lines, right? So both of these matrices are going to have a length of 500. And boom, and when there are so many lines, we actually get these nice patterns appear, which I find really beautiful. Look at this, it's just so beautiful. And you would think it's a 2D image, which it kind of is, but it's actually the combination of a bunch of lines, which I find beautiful. But okay, so this creates the image, right? But there is of course a bit more to do, because I do want to make this interactive, like how it is in the original P5.js sketch. So let's see, what do we need to change? Well, I want to change the amount of lines. I want to change the thickness of the lines. And finally, I want to change the size or the length or the radius of the lines. I want to change these 3 things, and let's just tackle these in order because we actually have all the parameters. It's just a matter of mapping things. So the amount of lines, as we have just seen, is determined by the length or the size of our jitter matrix. Right now it's 500, so we are going to have 500 lines. And if we want to change this dynamically, we can just send the message dim, and then I'm going to type in $1, which will be replaced by, in this message box, by the incoming number. So dim, and then the new dimensions of the matrix, the new length of the matrix, the new size of our jitter matrix is going to go right here, right? So the message dim, $1 goes into both jitter matrices. Now if I change this, type in 5, click this button again, now I have 5 lines. And I don't want to click this button again and again, so I will do the same thing. I will connect the second outlet of jit.world to this button, and now I can dynamically change the amount of lines. Right, so 2 lines, 5 lines, 15 lines, 100,000 lines, and then it just looks like a flat circle because it's just too many lines, but like 500 lines and further create these cool visual patterns. And if I want to map this to, I think it was the Y position of the cursor, right? Yes. So the Y position determines this. The Y position determines the amount of lines, so I can simply take my normalized Y coordinate right here. I can scale this 0 to 1, this is the input range, to let's say 2 until 150. Right, we can then use the send object, send amount lines, just to make sure patch does not look like a bunch of spaghetti. I will use a receive object here, receive amount of lines, go in here, and now it is going to be reactive to the Y position of our mouse. Beautiful. All right, and this Y position also affected the thickness of lines, right? So amount of lines is done. Let's do the thickness of lines. To change the thickness of lines, we have to change an attribute in jit.gl.mesh called line_width. When this is followed by a number, that number is going to be the width of the line. And by default, this is 1, right? Line width 1 is going to be the default value. But if I increase this, the lines are going to get thicker and thicker and thicker and thicker until they're so thick that, again, it looks like a flat circle because the lines are so thick, they're all blending into each other. And if I go less than 1, it actually becomes finer and finer and finer to the point where it just looks like a combination of a bunch of points, and this results in even more beautiful patterns. Oh my God, I just love these patterns so much. Look at this. It's just beautiful. It's just so beautiful that you can create all of these intricate patterns just by combining lines. I just find it amazingly beautiful. But okay, that's the Y position again. So let's take our Y coordinate and let's once again scale this. This time not to 2 and 150, but let's scale this to, let's say 0.1 to, I don't know, let's say 10, 0.1 to 10. And I will this time use a send object and name it thickness lines, send it here, receive it here, receive thickness lines, and put this here. And let's see. Yep, there we go. It's pretty much like the P5JS sketch. The amount of lines and the thickness of lines are determined by the Y position of the mouse. All right, and the final ingredient, I believe, is the size of this guy. The size of this guy, which was the radius of the lines, right? The thickness of the lines are done. Now I want to make sure the radius of the lines are done. And how did we set the radius of the lines? Well, in jit.gen, we had this fixed value, right? 0.5 is the polar radius, but now, finally now, I want to change this value to something other than 0.5. And I can do this by changing this from a constant value to a parameter. So the param object, and then the name of the parameter, and let's just call this size, and then the default value of that parameter. So now it is still 0.5, but since this is a parameter, we can change this from outside of the jit.gen patch. So I can make a message that says size, and then $1 goes into jit.gen, and now I can just send any kind of number, and that is going to be the new radius. And look at what happens. If I go lower than 0, it kind of starts extending in the opposite direction. So we can also achieve what we want to do like this. All right, and then it was the X position of the cursor that changed this. So I can scale the X position. That goes from 0 to 1, but I want this to go from -1 to 1. Right, so let's scale this and let's send this to, I don't know, radius lines. Not radius line, radius lines. All right, the X position scaled to -1 to 1, and then through the send object with the name radius lines, it will be received right here. Receive radius lines. There we go. Beautiful. All right, and here we have a beautiful shape, and we can play around with this as much as we want. Of course, as always, this is just the starting point, right? You can create your own variations on this. For example, you can try working with colors. You can figure out how to add colors to these lines using jit.gl.mesh. You can add some randomization to the position of these lines, or you can try exploring different draw modes of jit.gl.mesh to see what comes out. And if you really want to, you can even try to make this audio-visual in a way to control the parameters or modulate these parameters using things like amplitude and pitch and the frequency content of the incoming sound. This would add a really cool audio-visual edge to a generative artwork like this. In any case, I hope you enjoyed this. I hope you enjoy creating something like this. I hope you enjoy exploring the ramifications of this. And thank you for watching.